The meniscus is a highly specialized fibrocartilaginous structure within the knee which has many functions. Its primary function is that of load transmission across the knee, and we know that in a knee which has had a full meniscectomy, it decreases the surface contact area by 50 to 70%, and in some studies in knees which has had a full meniscectomy, it can increase contact pressures by up to 235%. They also have a role, an important role as a secondary stabilizer, particularly in AP stabilization of the knee. They have a role in increasing the articular congruity of the knee, and also a role in distribution of synovial fluid across the articular surface. Some people also say that it also has a role in proprioception as well. When I think about the meniscus, I think of it in terms of its macrostructure, and I divide the macrostructure into a cellular component and the extracellular matrix. Now, the cellular component is mainly that of fibrochondrocytes, and this makes up the vast majority of the cellular component. The extracellular matrix is mainly water, and it's mainly water, up to 70%. And the other part is what we call the ground substance. And the ground substance can be then divided into the non-collagenous portion, or the collagenous portion, if I can spell. And in the collagenous portion, we know that the vast majority is collagen type 1, up to 90%. It also contains some collagen type 2, 3, 5, and also 6 as well. The non-collagenous portion is made up of elastin and proteoglycans. So that's the overall kind of composition of the meniscus. If we then look into the actual structure of the meniscus, we know that it's mainly type 1 collagen, but if we draw a cross-section of the meniscus here, we know that it's actually made up of 3 distinct layers. Now, the 3 distinct layers are the superficial layer, the surface layer, and the deep layer. And this is important because then we understand how the arrangements of the type 1 collagen fibers actually lie. So in the very deep layer, the fibers actually run in the kind of C shape. So they run circumferentially, okay, in the very deep layer. So they run in line and parallel to the C shape of the actual meniscus. In the superficial layer, you mainly have radial fibers which interlink these C-shaped circumferential fibers, and you have the same also in the superficial layer. This is important is because the circumferential fibers, they actually allow the meniscus to resist these hoop stresses, and they're made stronger by these radial connecting fibers. This is also clinically important because studies have shown that actually when you repair the meniscus, a vertical based suture which comes in here, comes around the whole meniscus and ties up here, is actually much stronger than a horizontal type suture, because the vertical type suture actually grabs more of these C-shaped C-shaped circumferential fibers, which make it a lot stronger. In terms of the blood supply, we know it's mainly from the periphery, from the pre-meniscal capillary plexus, and this gives blood supply mainly to the periphery, And we know that the meniscus is divided largely into three zones: an inner third, a middle third, and a peripheral third. And these are known as the red-white or white-white zones, depending on the amount of blood supply. This is important because we know that tears in the periphery, in the red-red zone, or less so in the red-white zone, are more likely to heal than if you had a tear in the white-white zone due to the blood supply.